Thank you for coming, joining us in this interesting public lecture, WISE public lecture that we are happy to organize to reestablish links with Bruce Power. Before I start with the introduction of our speaker, let me make the required territorial acknowledgement. University of Waterloo acknowledges that much of our work takes place in the traditional territory of the neutral Ashinibaji and Haudenosaunee peoples. I should be better at this, need more practice. Our main campus is situated on the Hamilton Tract, the land granted to the Six Nations that includes 6 miles on each side of the Grand River. Our active work toward reconciliation takes place across our campuses through research, learning, teaching, and community building, and is centralized within the Office of Indigenous Relations. In fact, we at WISE, we do a lot of work with remote communities and indigenous people. Let me introduce our speaker. Danielle Lacroix is the Senior Director of Environment, Sustainability, and Net Zero at Bruce Power. She has worked in the environment field for over 20 years and leads the company's environmental protection and ESG program, including the Net Zero strategy, quite relevant nowadays. And that nuclear, I believe, nuclear power has to play or will play a major role. Daniel provides strategic leadership on sustainability-related matters such as climate change, environmental stewardship, and the stakeholder issues and interest management, and is responsible for directing the governance, coordination, communication, and management of sustainability-related issues for Bruce Power. Daniel is responsible for the development and implementation of a strong governance to ensure environmental protection and drive sustainability in Bruce Power's operation and in our partnerships, pursuing and supporting local projects that will help meet our environmental sustainability goals, including mitigating climate change by sequestering carbon, protecting our watershed, biodiversity, and wildlife habitat, and maintaining important wildlife corridors. Using operational integration and focused consultation and collaboration with key stakeholders and environmental regulators, Danielle leads her team with professionalism and integrity to drive operational support to ensure consistent performance that exceeds regulation and industry best standards, to be protective of the environment and secure our future. Thank you very much, Danielle, for being here. Really appreciate it. She's going to be basically introducing us or giving us an overview of Bruce Power and the work that is happening within Bruce Power in terms of climate change and net zero.
Okay, thank you very much. Thanks for having me here and inviting me here to talk about the role of nuclear, and thank you guys for coming and attending today to listen. You already covered the introduction, so just a little bit about myself, because I think maybe as I'm speaking, people might be curious about my accent, and I don't want that to distract you. I am born and raised in Trinidad, which is the southernmost Caribbean island. And then I came up here to the University of Guelph to study environmental engineering. I liked it so much, I stuck around for a couple more years, did my master's, again, in environmental engineering. And then worked a few years in consulting, first in water treatment design, and then in greenhouse gas management, inventories, and so forth, before I made the move to industry, which was a happy move for me. I really liked working in industry. So moved to work at Bruce Power, which is, I think you should all be maybe familiar. It's just about 2 hours away on the shores of Lake Huron, and it's one of the world's largest nuclear power plants. So that's a little bit about me. When I started in Bruce Power, I first started in engineering, working more on the conventional side of the plant, on main steam systems. And then I transitioned into environment, where I've grown and developed through the last probably 13 years, as stated. So I thank you, Claudio, for starting with the land acknowledgement, because that would have been difficult for me to pronounce. But I do, and I should have checked how to work the clicker. There we go. Since I'm representing Bruce Power today, I also do want to acknowledge that Bruce Power is located in the Saugeen Ojibwe Nation territory, and it is the shared traditional treaty territories of the Saugeen Ojibwe Nation and the Chippewas of Saugeen First Nation and the unceded Chippewas of Nawash First Nation. Bruce Power is dedicating to honoring history and culture of Indigenous peoples and is committed to moving forward in the spirit of reconciliation and respect with Indigenous communities that we work with. We're committed to strong and respectful relationships with the Saugeen Ojibwe Nation, the Métis Nation of Ontario, Region 7, and the historic Saugeen Métis. I still haven't mastered it. Okay, so a little bit of Bruce Power, and this kind of serves as an agenda of what I'm going to speak about today. So Bruce Power is Canada's largest private sector nuclear generator, producing on average 30% of Ontario's clean, reliable electricity. Our life extension program that I'm going to speak about today is planned to build out and provide clean nuclear power up until at least 2064, and it's one of Canada's largest private sector infrastructure projects. We're also looking under something called Project 2030 that I'll talk about at increasing the electrical output of our existing reactors on site to provide more clean electricity to the grid from now until until forever, but we're incrementally growing that until the 2030s. And we produce isotopes, so that are very important to the global healthcare system. And then I'll share, because of my background, a little bit about our sustainability and net zero program. So here's some cool facts about Ontario. Zero emission power, nuclear power, is already the backbone of Ontario's clean electricity generation. In 2023, between Bruce Power and OPG nuclear plants, we produced 53% of the electrical output to the grid, and this is against a nominal 60%, and this is because collectively we had 4 units in refurbishment, 2 at Bruce Power and 2 at Darlington for OPG. And so I guess what I wanted to highlight here is we normally produce about 30%, and this is less in these years, but until we get through these refurbishments and bring back more nuclear to the grid, that's where we're set at. So the province already has a deeply decarbonized grid in Ontario, and I'll just show you a comparison. And this is due to the high base load between nuclear and hydroelectricity. So here you can see, even when you compare to California and their grid intensity for greenhouse gas emissions, Ontario is substantially better. So let's fast forward to Ontario in the future. In 2050, there are various forecasts and projections that look at how much electricity demand is expected to grow over the next 3 decades. And these projections vary depending on how aggressively Ontario shifts away from fossil fuel powered sources. But I think we can all agree that what we can all agree on is that we're going to need more clean electricity. And so clean electricity is going to have a significant role in decarbonizing Ontario's largest emitting sectors, which include transportation, buildings, both residential and commercial, and heavy industries such as steel and manufacturing. And so this growth is happening at the same time, and Ontario's expecting to build 1.5 million more homes to support a rising population, and at the same time trying to attract new industry, such as building electric vehicles and batteries. So we have to do this in a clean, sustainable way. And if you look at these figures across here, that's almost 60% of growth of electrical demand by 2050. It's 91 million extra megawatt hours to the grid. So that's the growing economy and energy demands. Now we need to figure out how to get there in a clean, sustainable way. Ontario has already shown leadership in decarbonization efforts, and when we shut down coal in 2014, that is considered one of the most significant greenhouse gas reduction initiatives in North America. So Bruce Power played a role in this by returning the Bruce A units 1 to 4 to the grid, and that in itself provided 70% of the electricity needed to support the shutdown of coal. So as we fast forward to today, Ontario is building on its nuclear advantage with the release of Powering Ontario's Growth Plan. This plan was released last July and sets out the province's plan to build clean electricity generation, storage, and transmission infrastructure and facilities to accommodate this growing demand. And this plan relies heavily on nuclear to meet the growing demand for electricity. The Pathways to Decarbonization report identified a need for almost 18 gigawatts of new nuclear to the grid. So in December of last year, Canada was at COP and was one of more than 20 countries to sign a ministerial declaration to triple nuclear power by 2050 globally. This declaration signals global recognition that there is no net zero without nuclear. And Bruce Power was also participating in COP23, and in COP28, sorry, mixing up the year 2023. And in coordination with the ministerial declaration, joined 119 other industry signatories that are active in 140 countries in signing a net zero nuclear industry pledge to achieve this lofty goal to grow nuclear and triple by 2050. The pledge is recognition, again, that there's no viable net zero strategy without growth in nuclear, and it needs to grow at a faster rate than we are right now. So what's Bruce Power's role in this? And I hit it in the highlights. We're looking at a life extension program. So we have an existing 8 units on site, 4 at Bruce B and 4 at Bruce A. So we're looking at completing major component refurbishments to extend the life of these plants up until at least 2064. And then beyond that, the right now and ongoing is Project 2030 that I mentioned. And so this is investments to increase the output, the electrical output from the same asset using efficiency upgrades. And then finally, and most new, is the Bruce C. So we are starting the process to study the impacts and the feasibility of a new nuclear on the Bruce site. So I'm going to speak to these a little more, and if you have a question, that's great. Go ahead. Do we produce tritium? It is a byproduct of our operations because we use heavy water, so yes. Okay. So let's get into major component replacement details. So the major component replacement is a multi-year, multi-billion-dollar life extension program, and it's the largest clean energy infrastructure project, as I mentioned, that will secure a clean, reliable supply of nuclear power to the grid. The program includes the refurbishments of units 3 through 8, so that's 2 at Bruce A and 4 at Bruce B, through the next decade. And so units 1 and 2 at Bruce A was recently restarted and refurbished earlier on this decade in the 2012 era. So I like this little fact. The Unit 6 MCR was completed. It started in Jan of 2020, and it was completed on September 14th, 2023. This was 39 years to the date when its first in-service date in 1984. So it's a cool little fact. But what was not a chance was that it was completed successfully with an industry best safety rating for large projects. And this was achieved through the efforts of our employees, industry partners, and thousands of skilled tradespeople working arduously on this project to deliver it ahead of schedule and under budget. And the interesting part about the budget is we had a refurbishment agreement with the Independent Electricity System Operator, the ISO, that we projected what the cost and schedule would be. And when we did better, we were able to pay $50 million in saving to the ISO, which was then translated as a price adjustment to the ratepayers. So there was some benefits to that as well. And then right now we have Unit 3 at Bruce A under a major component replacement project. So the unit's not online. It started last March. And then Unit 4 will come offline at the beginning of 2025. And then we'll move through all the units there. So what we did though is our learnings, our lessons learning from Unit 6, we then applied those to the preparation and planning of Unit 3 so that we could further improve on schedule and budget, and we'll continue to do this along the way. So these learnings included innovations in tooling and inspections using more automation and robotics. And next, so I can take a little break too, I have a bit of a video I can share. It's only 3 minutes. I can click there about the MCR. You got it.
Nuclear power is lighting the path to the future. A future where clean, reliable electricity meets rising energy needs. A future with a prosperous economy founded on job growth. A future where new medical isotopes triumph over disease. For decades, Bruce Power has provided clean, reliable energy to Ontario and cancer-fighting isotopes across the globe, and will continue to play a vital role in powering a clean economy for the next generation.
Is that the only thing there? There's supposed to be one about NCR, no? Okay, no video there. There you go. There was a cool video, and maybe I could share the link after, that was talking about the innovations in tooling for major component replacement and how they can use robotics, and especially because they're working on a reactive phase, and so that can have dose to people working and tradespeople that need to continue working. You don't want them to get dosed up because there are regulatory limits. So these tradespeople were able to use robotics to do inspections on the calandria tubes within the reactive phase and do that remotely, saving time and dose. So it's safety benefits. Okay, so moving on to Project 2030. So I mentioned this a few times. It is Bruce Power's initiative that involves a number of system upgrades, efficiency upgrades, and power upgrades on each of the existing units that are operational. It will support Ontario's climate change goals by targeting a net site peak capability of 7,000 megawatts by the early 2030s, compared to 2,300 megawatts in 2016. Currently, we're at 2,570. So the additional generation through these series of projects is almost equivalent to adding a 9th large-scale reactor unit to the site, and it does so without the need for any new infrastructure or impact assessments or onerous processes to get there. So with Ontario anticipating an increase in demand, and we know this demand exists now as well, this provides an additional 0.7 to 1, with the potential to up to 1 gigawatt to the grid. Then there's the Bruce C. So with the support of the Ontario government in powering Ontario's growth plan, Bruce Power is conducting an impact assessment to create the option to build an additional 48 megawatts of nuclear generation at our site. This is called the Bruce C project, and it's meant to complement the existing Bruce A and Bruce B units on site. And we feel that Bruce Power is uniquely positioned for this potential expansion because we have decades of experience, a well-studied and well-understood site. We have space for the expansion on site. We have a strong environmental protection program, strong community support, and an experienced and professional workforce in the area. So major projects such as this will require an integrated impact assessment. So the impact assessment is run by the Impact Assessment Agency of Canada alongside the Canadian Nuclear Safety Commission, who is the CNSC, who's our life cycle regulator. And we plan to advance this impact assessment with engagements with indigenous nations and communities, the local municipalities, and the broader public. It is currently technology neutral, so we're looking at a various number of technologies for reactors to form a bounding case in this assessment. So that's the potential for Bruce C. And then, yeah. Yes, it is not a planned project yet. It's not funded or approved, but we're starting the impact assessment work. So we're studying the feasibility and the potential impacts of this project. So that is currently not our focus, because we're looking at 4,800 megawatts, but as I said, we're technology neutral. So we released a request for proposal for projects. So various proponents are presenting to us options, and we'll take that through the impact assessment process. It seems unlikely it would be SMRs given the space and the megawatts that we're trying to achieve, but I can't say no. I don't mind, but okay. Okay, so I spoke about the electricity generation, but I just wanted to highlight that it's the value proposition of nuclear is more than just clean electricity. We pride ourselves in having a strong sustainability program which spans environmental, social, community, and economic areas and impact. We have made a commitment to net zero by 2027 that I'll speak about a little bit more. And we have a strong commitment to our local community because we recognize the importance of having strong community support being a nuclear generation facility. And so we're close to our community, and we fund a number of sponsorships and donations there. Even we have an environmental fund where we sponsor environmental restoration and protection activities, as well as offsetting programs, like in terms of the fisheries, because we have an impact from our cooling water on pulling in and potentially pulling in fish. We have a fishery offset projects to ensure more production in the area. So, and then finally, I'm going to speak about our medical isotopes. I should get better at clicking, but here we go. So nuclear isotopes have an important role in the global healthcare system. We produce two types of isotopes, cobalt-60, which is used in medical sterilization, and high specific activity cobalt, which is used to treat brain cancers, brain tumors, and breast cancer. And starting last year, we started modifying our adjuster rods within the reactor units to make them heavier and essentially produce more cobalt to meet global demands. And in 2022, we installed an isotope production system in one of our Bruce B units, in Unit 7. And this IPS, isotope production system, we can now produce short-lived medical isotopes. So we're currently producing lutetium-177, which is used in precision oncology for targeted therapy of a growing number of cancers, such as neuroendocrine and prostate cancer. And just last week, I don't know if you follow social media, but we announced the introduction of a new production line of the IPS, thereby doubling our production capacity for lutetium-177. So that was pretty exciting. And another good point about this is that we have partnered with the Saugeen Ojibwe Nation in a historic collaboration to market these medical isotopes. So this includes an equity stake for the Saugeen Ojibwe Nation and a revenue sharing agreement that provides direct benefits to the community for the marketing of isotopes produced through our IPS. So that's isotopes. Then, clean energy credits. Has anybody heard of these yet? From the ISO? Okay, so I guess it's new, and it is fairly new. So a clean energy credit is the environmental attributes associated with the generation of 1 megawatt hour of electricity from a non-emitting source, but it needs to be recognized as a non-emitting source in Ontario's Clean Energy Credit Registry. So you might have heard of renewable energy credits. This is prominent in the US. So it's similar concept. It's just the clean energy credits can apply to nuclear because it's non-emitting. So in March 29th last year, Ontario launched the Clean Energy Credit Registry. And this registry can be used as a tool for Ontario businesses to meet their own climate change goals. So it's a voluntary market essentially, and so they can meet their climate change goals by demonstrating that your electricity used is sourced from a non-emitting source. So it is a market tool. And it is intended, this registry is intended that it's used for the exclusive use of Ontario companies or load customers. And that way we're ensuring that all the environmental attributes or benefits from the clean energy stays within the province. And the other good thing about this is any proceeds from the sale of clean energy credits to, say, Ontario businesses will help keep the cost to the ratepayer down because the sales go back to the ISO, the proceeds from the sales. And it also funds the construction of clean electricity projects in Ontario through the Future Clean Electricity Fund, which was recently released. So this fund will help Ontario build its clean energy advantage as it competes for and attracts new clean manufacturing and businesses such as electric vehicles, battery manufacturing, clean steel, and other sectors. So that's a little bit about clean energy credits. And in a similar concept, we took this one step further. If you're considering what are the environmental benefits of additional or incremental non-emitting nuclear power to the grid, I spoke about Project 2030 before. And so if we are investing on an existing asset and there are no additional greenhouse gas sources, so you're investing to generate more power for an existing asset and providing additional or incremental output to the grid, what is the benefit of that? So it highlights that each additional baseload megawatt that is generated by a non-emitting source is avoiding the need to dispatch additional natural gas generation, which is the marginal generator. So clean megawatts are avoiding the need when we have peak needs that put natural gas on essentially. So it's thereby, by providing this, we're avoiding greenhouse gas emissions. So from natural gas electricity generation. So Bruce Power, in collaboration with GHD, a consultant, has pioneered the development of the first carbon offset protocol, and it's tailored for nuclear generation, specifically for the incremental power output, not the base load, not the normal. And this protocol was structured and followed from the Alberta emission offset system to maintain alignment with the projects and protocols they have registered in the greenhouse gas in the CSA Clean Projects Registry and built in alignment with ISO 1464-2. So our protocol exists right now. It's been validated by an accredited third party, and it's something we're trying to build on. Okay. And then I pivot on to the sustainability program a bit. So our approach to sustainability prioritizes responsible business and being a steward for the environment and the communities that we operate with. We also try to support the provincial and federal climate change goals with our own net zero strategies and providing clean electricity to grid. And we try to contribute to the economic growth, innovation, and environmental protection. So for us, sustainability is built on 4 pillars. It's the environment, our people and the safety of our people and the development of our people, our products and services or our supply chain, and our community. I think I've mentioned these a few times. And so, just gonna, click in. So, our sustainability performance. We're recently releasing our annual sustainability report. It might be today, it might be next week. I'm waiting to see. But these are some of the highlights from our sustainability report in our 4 pillars of environment. It's not quite in order. Products and services, people, and community. So this last year, we were able to demonstrate a 25% reduction in our greenhouse gas emissions, net greenhouse gas emissions. Almost 90% of our products and services were spent in Canada, with 59% sourced from suppliers in the Indigenous Relations supplier network. We had a 31% hire of women into non-traditional roles, such as operations and maintenance and trades. And we spent over $4.1 million in sponsorships and donations within our community. So those are just some of the highlights. And net zero. So this is something I'm proud of, our Net Zero 2027 commitment, as we were the first nuclear operator in North America to set such an ambitious and timely commitment. It is based on our Scope 1 and Scope 2 emissions, which we have most control of. And we didn't just set a Net Zero 2027 target, we set interim targets along the way of increasing reductions year by year from 2021. And this was to ensure that we were continuing to drive performance and not just sitting waiting for innovations. And we've been achieving our targets. And in 2023, I just mentioned, we met our 25% net reduction, and we did so without the reliance of any offsets. Previously, you could see the yellow, we did require some offsets. But we achieved our goal by significant reductions in our Scope 1 emissions through an optimization in the testing of our standby generators, which are large generators as part of our safety program, but they have a lot of fuel. And then we also, by optimization of our building use and heating within our buildings. And I will say we did incorporate the use of clean energy credits in our 2023 goals and found them to be useful to offset Scope 2 electricity emissions. So while I do note that we are going to have some reliance in CECs and offsets in the early phase of our program, we're still working on building real reductions and innovations into the longer term, but I firmly believe we need to start somewhere, and all things count. I'm going to talk about that a little bit more. So this is just a bit of our high-level strategy. So we set our baseline in 2019, and we completed our greenhouse gas emissions inventory to determine where they are, what our greatest sources and what our opportunities for real reductions. We start at the top looking for avoidance and reduction opportunities. What can we completely eliminate or reduce? And then we focused on, next, substitutions. Where can we find cleaner sources of energy? So on our site, we had steam heating from a steam supplier that burns natural gas and travels it across a long way to our site. And so there are a lot of losses from that, which increase our greenhouse gas emissions. So we went to more localized sources. It may not seem intuitive, but we were able to have a significant reduction in emissions that way. And then we also looked at building optimization, where we have a lot of older buildings on site. Can we consolidate and keep people together in one building versus heating and maintaining another building? So that was a big opportunity for us as well. So that's the second part. And then where for each year our interim targets can't be met with the progress we've made on those activities, that's when we look to find CECs and offsets to ensure that somehow we're achieving our goals. And I'm going to just speak a little bit more on offsets after, but I did want to touch on Scope 3 emissions. So for a nuclear plant that's generally clean, Scope 3 is the most significant. So Scope 3 are the least direct emission sources, and they're usually the sources of your suppliers or the downstream users or the transportation of your product. For us, we have clean electricity, so our downstream is pretty good, but our upstream is the most significant, and I'd say about 97% of our emissions come from the goods and services provided by our supply chain. And so from 2019, we did an inventory kind of based on spend, and we're really spend. And each year we look at what the Scope 3 looks like, and we're really starting to exert more influence in our supply chain, and I feel that's where we can have the biggest impact and influence to improve. Last year, we sent out a note to them asking for them to disclose their greenhouse gas emissions to us so that we can be better at accounting, less conservative, more actual. And we asked them to consider their own reduction plans. This year, we're being a lot more aggressive and forceful because we can have that influence. They do a lot of business for us, and so we can ask and really, really influence improvements there, and that's what we plan to do. Okay, and this one is where I'm going to wrap things up and talk a little bit more about offsets. So I stated earlier that where we can find no further reductions from our own direct emissions, we're going to look at what offsets exist. But we don't want to just purchase any offsets and use it towards our program. We want to have more of a local influence. And so we've established a carbon offset purchase policy that really sets out to ensure that the integrity of the offsets we use, that they're actually additional, that there's strong transparency, that they're in an accredited, their protocols from which they're developed are accredited. And most importantly, I mentioned we wanted it to be local. I mean, you can buy offsets from China at a certain price, but we really focus on they had to be from within Ontario, because we're all part of the Ontario clean energy economy. And more so, we try to influence projects within our regional area, within the Bruce Grey territory, in the Saugeen Ojibwe Nation territory. So in 2021, we announced, or 22, I'm forgetting now, a $1 million carbon accelerator fund. And so this was a call to projects, or call to proponents to come to us and suggest what they can do in terms of a carbon offset or carbon sequestration project to do better within our area. And because Bruce Power is situated in a highly agricultural area, we got nuclear, we got agriculture, we really, put out the ask to the local farmers and ranchers. And so from this Carbon Accelerator Fund, Alice Gray Bruce was successful. They came to us with the New Acre Project. And the New Acre Project really looks at developing over 600 acres over a 3-year period, so 200 acres per year, and implementing more sustainable practices on these lands. So Alice works with the local farmers and ranchers and helps them implement and monitor the success of these projects. And then their organization is working on developing an offset protocol or a methodology. So they've completed the second year. I think they've just released their second year progress report that demonstrates the carbon benefits and the other benefits from these projects. Just this month, actually. And we're now moving into the third and final year of this project. I'm sure it's going to continue. So they're working on their methodology. Their hopes are also to get it registered in the CSA Clean Projects Registry, but they're still in the early stages of validation of their protocol. I wanted to highlight that while there are carbon sequestration benefits, the ones that we can get accredited or counted in a protocol may not be all there is. But there are other benefits too, like these projects really enhance climate resilience, they increase farm productivity, and generate additional ecosystem benefits. Their report talks about the increase in biodiversity, abundance, and diversity in the projects, in the acres that they've implemented these projects. And the other interesting thing that they're doing is they're using innovation. And so they have a number of technology pilots, one of which is the Albo Climate's remote sensing and machine learning solution that will help them in the monitoring and quantification of the carbon sequestered in the soil. So I don't know if I can, my words, demonstrate this project. So this is another attempt I tried for a video. So let's see if this one works. And this one, I'm in it, so that's a bit embarrassing.
We all want a world with clean air, thriving forests, and pure waters. But as our population grows, climate change and land use are taking a toll.
Ensuring a reliable supply of clean, non-emitting energy for increasing demands is one way that Bruce Power is helping to protect the natural environment. By reducing our own operational emissions where we can and launching progressive initiatives to reach net zero by 2027.
In partnership with Nuclear Innovation Institute, Bruce Power formed the Carbon Offset Coalition and assigned a $1 million Carbon Accelerator Fund to engage our communities in counteracting emissions when alternative sources aren't possible. Bruce Power has invested in Alice, a not-for-profit organization that promotes land stewardship.
The New Acre Project is a partnership with Bruce Power and Nuclear Innovation Institute. It's a partnership that takes marginal farmland and have that conservation and agriculture connect. It's important as a farmer or producer myself to have clean air, clean water, just increasing biodiversity on the landscape. The suite is endless of the benefits it provides.
This project has shown remarkable success in its first year. 20 farmers have developed 200 acres of nature-based projects, expected to offset 2,737 tons of carbon emissions over 5 years. By the third year, Bruce Power will have helped farmers in Grey Bruce produce 600 acres of new nature. Not only will this offset upwards of 6,000 tons of carbon emissions, but it will have a host of biodiversity benefits and demonstrate the impact of nature-based solutions on environmental challenges.
Thanks to Bruce Power, our region has become a center for nuclear innovation, but has long been an agricultural hub. And innovating agricultural practices is essential in meeting climate change goals and getting us to net zero by 2050. For nearly 2 decades, Bruce Power has leased this land next to the visitor center to the Cruikshanks, a local farming family who understands the value of sustainable agricultural practices.
Well, one neat thing that we're doing on our farms when we plant wheat by broadcasting it above a growing field of soybeans. And so the wheat grows under the soybeans, and when we harvest the soybeans in the fall, we're left with a beautiful green wheat field already planted. It saves our fuel by about 75% of the diesel that we would normally burn planting. For us, it's a very sustainable method of agriculture. Environmental stewardship and economics, we found that they marry very well together. We find that usually environmental initiatives can actually save farmers money. We've never encountered an environmental initiative that we've employed that hasn't also resulted in an economic advantage. It's important to farmers that the next generation takes over. They want to keep their farms sustainable for the next generation so that their families can continue on the same land.
Energy and agriculture are united in the spirit of innovation, collaborating to fight climate change and inspiring hope for the world we all want.
Okay, so that's where I end. I think I presented the various assets of nuclear and its role in Ontario, so I'm here for any questions or discussion. Oh, thank you.
Thank you very much. Just a second. This is being broadcasted, and also we are taping it. So the reason for not having questions in the middle is because we require a microphone.
Sorry, yes.
So that's the reason for that. So with that, I open the floor. Is there a microphone on the back? Just a second. Get a microphone first. Thank you, sir. So people online can hear us, and we can have a recording of this. Is it on?
Thank you for your presentation. You mentioned like emissions and the different scopes for emissions, but like I'm curious. I mean the emitted sort of radioactive byproducts, are they considered as part of the scope for emissions, or that's a separate thing?
So they're not part of our net zero, like greenhouse gas scope, but we do measure and monitor our radiological emissions and effluents, and it's regulated under the CNSC, the Canadian Nuclear Safety Commission. So that information is publicly available. The CNSC hosts a website that reports that for each nuclear operator. And I could say that when we do measure and monitor our effluents and emissions radiological, we also do monitor the environmental media. So the air, we have tritium monitors and gross gamma monitors. We also look at vegetables within our local community, dairy, eggs, many different things. And we take all that information and put it into a model to do a dose to public estimation. So each year we're regulated to do this, and our dose to public is very de minimis. It is 1.4, this year, 2023, we reported our dose was 1.4 microsieverts versus a regulatory limit of 1,000 microsieverts per year.
As a follow-up, just the nuclear material that's kind of emitted as a byproduct, kind of waste sort of material, where is that stored, or where is that?
The waste?
Yeah.
So the waste is stored two places. On our site, so the nuclear fuel waste, which is a more high-level waste, that's first stored within what we call these fuel bays. So they're pools within the nuclear plants. And we hold them there for several years for them to decay a bit, move it to a secondary pool for longer decay, so it's 6, then 10 to 15 years. And then it gets put in containers and stored in a building on our site. Yes.
Following up on this question, because I was asking that over lunch, how big is this? How much?
So I was trying to get the full answers, but on our site there is a building. There are waste containers in there. I cannot say exactly how much it's spread, but I did some research following our conversation, and the U.S. facilities also did a study. So say the U.S. nuclear power plants, they have 54 nuclear power plants, and so all of their waste, fuel waste from the 1950s to now, they did an assessment, could be stored in a American football field, 10 yards deep. So it's really not a lot of waste. All of our waste from Bruce Power since the 70s when we started till now is stored in a relatively small area in a building on site. Yes. So currently the plan is right now on site, but I'm sure many of you have heard about Deep Geological Repository. So the NWMO, the Nuclear Waste Management Organization, is looking into that and has been going through engagement with communities. So there are 2 remaining communities now, one closer to us and one further up north. And that plan, once approved, will be the long-term optimal plan for nuclear waste.
Okay, other questions, please. Yes.
Yeah, just following that, I actually work with that project, Nuclear Waste Management Organization,
Okay,
and
Ben.
it's a 40-year, $40 billion project. So this brings me kind of my thoughts. I don't know why we call this clean energy instead of simply saying carbon clean energy, which is a much more truthful way of saying things. The second thing is, it could be a sustainable one if you really have a closed cycle with fast breeder reactors, which Canada is not doing any research as far as I know. But with the waste of something like Bruce Power Plant, if it goes into other fast breeder reactors, it's possible to be a closed cycle. Then we could claim it is sustainable. So I don't know why we don't say the right words. It only makes us feel like we are just hiding something. And
I see.
It's not that easy to hide anymore. So I prefer not to say clean energy. I would say carbon clean energy. I would prefer not to ignore this long-term nuclear waste. We are not still sure what we're going to do. I mean, we're still in the design.
We still don't have
Yeah, we don't
approval.
know what we're
You're
going to do.
right, but
And
we're
everywhere in the world, not only Canada, but everywhere, almost in everywhere in the world. Nobody
for
knows what they're
Finland.
going to do.
Okay, I caught the first question. So why do we say clean? It's a bit bold, because we're really speaking about non-emitting greenhouse gas, but also in terms of our effluents and emissions, there are many other things than non-carbon that we're not emitting. And if I can prompt folks to look at our annual environmental protection reports, you can see that we report every possible from radiological to hazardous substances, and they are de minimis compared to other types of power generation plants other than hydroelectric. So it is a matter of opinion, and I hear your counsel. Sometimes we focus more on non-carbon emitting, but the actual radiological effluents are a very low impact. They're not having any impacts on the environment. Waste is not what we're considering in effluents and emissions, but you're right. But right now the plant is safe. The amount of waste is maintainable on our site, and it's not like we're creating landfills overall. But you're right. We need and we want to see that long-term waste plan.
Thanks very much for the presentation. Really interesting. And as for people interested in the climate change debate, policy development, provincially and nationally, can you share with us an association or a grouping that you're thinking is having particularly useful inputs into the way things are being discussed and taken forward?
Just to clarify the question, like, are we working with a group that we find helpful in terms of climate change?
Yeah.
Yeah. That's a great question, and I honestly feel like my department sometimes feels overwhelmed with the various amount of data sources, and how do you complete a climate vulnerability assessment when the data is so far-ranging? We've worked with a few different organizations in the past. We've worked with the Climate Risk Institute, and we also currently are working with EPRI, the Electric Power Research Institute, the Climate Ready Project. And what I like about the work with this group, it's a number of electric power industries. We all have the same stakeholder type of interest, and they're really working to develop common frameworks for how we assess what climate data to use, how to assess and how to complete vulnerability assessments, and how to prioritize risk. So we're in year 3 of that 3-year program, and I'm looking to see the results now, but it's a slow game, I think.
I have a follow-up question in terms of, because the issue of clean energy is, there's no clean energy.
Yeah.
Every form of energy production produces some.
Has its impacts.
So we have to be clear there is no free lunch. Now, in terms of, one of the major concerns about nuclear is the cost. That's one of the major sort of drawbacks as compared to other forms of energy. And that appears everywhere. But I was very interested in the comment you made about that expansion that was actually under budget, which is unheard of. So can you comment on that?
I think all I can comment is yes, we were very proud. I think the nuclear industry did not have the best reputation of cost and budget. Even on the Bruce site, our Unit 1 and 2 restart at Bruce A was well over schedule, well over budget. But I think we've learned from that as an industry and really put in a lot more effort into the planning and preparations for these large outages. And so Unit 6, I think all I can say, did come back in well ahead of schedule on that interesting date and under budget. And part of our refurbishment agreement with the ISO puts, we submitted a budget for the first one, but then the second and third all have to come at lower cost and lower schedule. So it's really driving us towards innovations and being smart and learning from the previous.
What was the cost of the whole, you said 50 million the savings?
I don't have that number in front of me. But I did once know it, but I don't want to say it wrong.
Okay.
It's a multi-billion-dollar project across all the units.
Okay, so if there are any other more questions before I open the floor for another question from... Yeah, there's a question here. There'll be time for you to approach the presenter and discuss with her any additional concerns.
Great, thanks. I just had a question. I know you said that as part of the refurbishments that sort of the efficiency and output is being improved. improved through engineering solutions. Is there information on what kind of solutions or what that looks like? I know it's probably a separate talk, so I don't want to.
I don't necessarily have the details, but I have the ideas of what it is. It's upgrades to our generators, essentially, and turbines that will ensure that the megawatts are going to the grid. There are various projects with our heat exchangers. We have like a series of heat exchangers before the steam gets to the turbine. So it's a bypass of one where we've studied that the efficiency would be better without it. So it's just a series of different projects, and it's even our transformers. So I'm not much of an electrical engineer, but it was upgrades to our transformers suddenly gave us more megawatts to the grid.
Okay, yeah, we have questions online. So how is this going to work? Okay. Microphone to the computer.
Okay, the first question is, does Bruce Power have any plans on geothermal?
Not that I'm currently aware of, but when we're thinking of new build, we definitely want to have the most innovative sort of, we were speaking earlier about district heating, and there are really opportunities to explore whatever makes sense now. Retrofits are sometimes difficult in large nuclear plants.
Perfect, thank you. Question number 2, what are you including in carbon dioxide emissions employees driving to work every day in an internal combustion engine car?
Yes, so that's covered within our Scope 3 emissions, and we do include that. So I'm hoping our sustainability report is released today. If not, it's next week. But we have that information in our sustainability report. We also have a net zero strategy report. If you Google it, you can see those
So,
details.
follow-up question to that one. All of your transportation needs are being addressed with electric vehicles, or planning to do that?
All, like for employees?
Most of it, yeah, for employees and
No, we provide
Fleets,
the
or fleets.
infrastructure to support the employees, but, you know, who's to say as we do more engagement about the business commuting, I talked about we're focusing our Scope 3 on our suppliers because that's the biggest piece of the pie right now, but we do plan to look more in the business commuting, like Bruce Power does have a bus that runs to sites. We're looking at how we can improve the employee commuting travel as
how
well.
about your fleets?
Our fleet, yes. So our fleet, we are looking at electrification and optimization of that. It's not happening instantaneously, but it's part of our 5-year plan. Good question.
Question number 3, once net zero is achieved, Scope 1 and 2 emissions by 2027, does Bruce Power have any plans to tackle Scope 3 emissions, supply chain? What could that look like?
Okay, so that's what I try to mention. So our focus is on Scope 1 and 2, but yes, we do want to tackle Scope 3. We haven't been setting targets as yet because we're looking to get the information from our suppliers first and influence them, and then we'll come back with more aggressive targets, but we'll take
Thank
that
you.
road.
Yeah, one last question. Hey, wait for the microphone, please.
The topic of sustainability was mentioned earlier. I'm wondering, the base nuclear fuel used, for the reactors, because they're not fast breeders. I mean, technically, it would like run out in 100 or some number of years. Technically speaking, 70 years. Okay, and so unless newer
Fuel.
technologies were implemented, it would not. I mean, it's a long time, but it would not be sustainable, right?
I'm not familiar that we're concerned about the resource of our fuel because we have large mines in Saskatchewan and we don't use enriched fuel, we use natural fuel. So it is, maybe I just don't know the answer to that question, but it hasn't been a concern raised to me.
Okay, well, thank you. I guess we run out of time, but if you have any further questions, comments,
Yeah,
please
I'm
approach.
here.
Danielle's going to be here for a few minutes. There's some a little bit of food on the back and coffee, so feel free to to eat it because otherwise it goes to waste. Okay, thank you very much. Thank you,
Okay.
Daniel.
Thank you.